This video is recorded to help my students to understand how to implement the linked list. This is a project of the course. When the student gets this project, the first thing the student needs to do is to read through this .h file and this .cpp file to understand what kind of functionality you need to implement and what kind of test your function needed to pass. So I will not read through all those precondition, postcondition of each function here. We can just give an example. For example, this list length function. Then student need to understand header PTR is the header point of a linked list. The postcondition, the value returned is the number of rows in the linked list. The list itself is unchanged. So then you read this grid file, you will say the test one will test list header insert, list header remove, list insert, list remove, list clear, and list length, those functions. So the student are recommended to read through this test one function, then to understand what kind of test the program gave. So that will help you to implement because you know your code should pass what kind of test. Okay, so I will not type all those, but when I do it, I would like to copy over all those function head with the precondition and the postcondition. So when I implement, I will understand what to do. Also, every time I just implement functions for one test first. When I implement function for test one, in the main function, I will comment away or the code that will call test 2 and test 4, for example. I will do this. I will comment away those code. So after I finish implement of all those functions that are tested in test 1, I can run the program, say if test 1 really passed. After that, I can begin uncomment the code for run test 2, right? Then I implement all the functions that the test 2 will test. So I step by step doing those. Okay, let us first say what the test 1 function implemented. The test 1 function tested the following functions. One is list length. Look at the list length. Actually, it's very simple. You let since it will return you a SST, which is the number of rows in this linked list. So I first declare SST result equals 0. Then I step through this linked list. As long as header PTR is not allowed, I increase result by 1. Then let my header PTR point to the next load, equivalent by header PTR equal header PTR link. Then finally I return the result. Okay, so the list header remove. Now pay attention to the difference. Here you will call by reference. Okay, so this formal parameter and actual parameter header PTR will be the same. So you need to be very careful here. Like the previous one is called by value. So even you change header PTR inside the function, it will not affect the actual parameters header PTR. Okay. Now let's say this list header insert also very simple. You first declare a node point temp point to a new node. Then you let this new node state is the entry you want to insert. Then this new node his temp node his link is the header PTR. Then you let header PTR point equal to this temp. So you can draw a picture to understand this easily. Okay. Then we have list insert. Now you need to understand that this previous PTR we don't mean it insert this entry to the previous PTR place. Is insert a new node that followed by the node that the previous PTR points to. Okay, so the new node has been added after the node that the previous PTR pointed to. So again, we first created a temp which the node pointed to a new node and that data, that's entry. The new node his data is equal to entry, but this new node his link is previous PTR's link. and this previous PTR's link will equal this new load. So you draw a picture, you will see what's going on. Okay. Now, then we'll of course implement list header remove or list remove, list clear, and list search. Okay. List locate. Now, for example, what list locator say? List locator precondition: header PTR is the header point of the linked list and the position greater than 0. Post condition: the point returned points to the load at the specified position in the list. The head node is position 1, the next node is position 2, and so on. If they load such a position, then the null point is returned, and the list itself is unchanged. Now, so I need to use a count to control the loop because this count need less than the position. So I start from count equal 1. As long as the header PTR not equal null and the count less than the position, that means I didn't go through all those positions yet. What I will do, I will move header PTR equal header PTR's link. Okay, then I increase count by 1. Now, when this loop finish, either header PTR already equal null, right? Which means you at least is short than the position. In that case, you return header PTR which is null. Or the count equal the position. That means you exactly at that place, and your header PTR is point to that position, right? So you return header PTR. That's also okay. So list occurrence, which count how many times the target show up in the linked list. Again, since you want to count, so I create the result count equals 0. As long as header PTR not equal null, and then I check header PTR's data, the load he pointed to. That's load's data, matched target or not. If it matches, then increase count by 1. Then I move to the next load, right? Finally, I return the count. Okay, so those basic functions, I believe students feel okay. The student feel difficulty is this list tail attach, list tail remove, and those functions. So I will give 3 examples here. I already gave students pseudocode. The students just need to understand how to translate this pseudocode into the code. Of course, the student should understand why the pseudocode work first. Now, the idea. So let's read the precondition. Header PTR is the header point of a linked list. Post condition: a new node containing the given entry has been added at the tail of the linked list. If this happens to be the first node of the linked list, then header PTR now points to this node. Otherwise, header PTR is unchanged. So basically, if your header PTR originally is null, then this new entry is added. Okay, so I will say if header PTR equal null, right? That's it. Call list header insert. So I will call list header insert. List header insert will have header PTR and give me an entry, then return. Okay, so that's I solved the first special case. If it's not, then declare local variable called node point is tail PTR equal header PTR. Because I do need attached to the tail, so first I need to find where is the tail yet first, right? As long as the tail PTR not pointed to the tail yet. So how do you know it's pointed to the tail? Because if it pointed to the tail, then its link is the null. So, well, the tail PTR is link not equal null yet. Okay, then I let tail PTR move to the next one. So tail PTR equal tail PTR his link. Okay. Now, after that, after this while loop, my tail PTR will really point to the tail of this linked list. If it's pointed to the tail to this linked list, then what I will do, I will insert a new node after this tail. So I just call the list insert function. Because list insert function, you give me a previous node, which is the tail PTR, then I will insert the new node after the node that the previous PTR pointed to. Now my previous PTR is just the tail PTR. So I insert this entry to here. Okay? This is list tail attach. Now, let's say what is list tail remove? List tail remove, I need to remove this the tail of this linked list. Now, you need to consider the special case. The special case is first, the linked list is empty. Then nothing, you don't need to do anything, just return. Second, if there is only one node in the list, then you just remove this node. But this node is head, so you need to call list head remove, then return. Then you need if more than one node, then you need to find that you want to remove the tail, right? So you need to really find the previous node before the tail. Okay, you need to find the node before the tail. So here is how we translate this. If head PTR equal null, that means list is empty. You just simply return because there is nothing to remove. Now, if the head PTR link is null, so if head PTR his link is null, that means what? When I have one node here, then what I do, I will call list head remove. Then this call head PTR list head remove. Then need a return. Okay, this handle the special case. Now, if this not a return, that means I have at least two nodes. Okay, so now we declare new node point. I call it a tail PTR. This tail PTR equal head PTR his link. I need to know who is the tail, right? Okay. Now, then I need to declare this previous PTR equal head PTR. Previous PTR equal head PTR. Now, pay attention. The tail PTR point will eventually point to the tail. Previous PTR pointed to the node that before the tail. So now, at this moment, tail PTR not pointed to the tail. Previous PTR not pointed to the node before the tail. So I need to use while loop to move forward those two to their right position. So as long as tail PTR is link not equal null yet, that means tail PTR not reach the tail yet, then what I do, I will move tail PTR forward. Here's link. I also move previous PTR forward. Right? I move those two forward. Now, notice that previous PTR, this type here, need a lowercase vious. Previous PTR equal what happened? Okay, let's see. Previous misspell here. Okay, previous here now. Okay, not previous or smell good. Spell good. Okay, please note that after the while loop, tail PTR points to the tail, and the previous PTR points to the load before the tail. Okay, you need to notice that. Now, we want to call list remove function by using the previous PTR as the argument. That means I really remove the tail, right? Okay, so I will just say list remove, then previous PTR. That's it. Okay, so now let us comment away the test 4 part. That's the part I want to comment away. That's the only thing I did not implement yet. Then I begin run the program, succeed, and you can see what is the grade. He said equal point is 8, so all the tests we passed, right? Okay, if you want to see clearly, it's here. Show the list head insert, pass the test, pass the test. So the first test we pass, got a 5 point. The second test we pass, get 1 point. The third test we pass, get another 2 points. Now let's continue to implement list copy. First, you should write down the pseudocode first and understand what's going on. So for the list copy, if source PTR is null, then we have nothing to copy. So your header PTR should be null and return. Now, if it's not source PTR not is null, I start with header PTR set to be null, then we copy first load by call list head insert to insert the data of the first load of source PTR. So other than that, then we need to declare load tail PTR points to the load that header PTR points to. Then we begin keep move forward the source PTR and keep update the tail PTR and keep copy a new load to the tail. Okay, so here is how we implement. So if source PTR is null, then I will let header PTR to be null and return. So I will add header PTR equal null, equal nothing to copy and return. Okay. Now if I don't return, I first set header PTR equal null, then copy the first load from the source PTR. So I will do this by call list head insert header PTR, and I will insert the data which is source PTR his data. Okay, call them. Then declare the tail. So I need to declare tail head load point tail PTR first equal header PTR first, right? Then now as the source PTR's link is not null, so well source PTR is link is not null. That means you still have more to copy. Okay, then first forward source PTR equal source PTR link. Okay. For link, then call list insert. The previous is the tail PTR, right? Then I will insert the source PTR his data inside. Data, okay? Then update the tail. So now the tail PTR equal tail PTR link. Then I go back check if source PTR already reached the tail, because source PTR has link equal now, which means it reached tail. Then I return tail head PTR. Okay. Now here is an error. He said this a void function, so I should not return head PTR. Okay, my mistake. So I should just simply say return, because this is a void function. This is called by reference, so your head PTR don't need to return directly. The value is that means the actual parameter and the same formal parameter point to the same linked list. Yeah, my mistake. Okay, so let's see list copy front. So what this do? This, if you read the precondition, source PTR is the head point of a linked list. Post condition, the value returned is the head point for a new list that contains copies of the first n node from the list that the source PTR pointed to. So if the less than n node in the source list, just copy all nodes and done. So first I did declare a node PTR, a node point, I mean head PTR. Okay, first initialize to be now. Okay, so if the source PTR is now or n equals 0, if source PTR equal now or n equals 0, that means nothing to copy. So I just return now. Okay. Now, other than that, I call list head insert to copy the first node. So I will do list head insert the head PTR and copy the first node source PTR his data, which is his first node. Then declare the tail PTR pointer to the head. So I will say node point tail PTR equal the head PTR, right? Then declare the size t count equal 1. Now the condition is as long as more source to copy, so which means source PTR not is now yet. As long as source PTR is link not equal now and count is less than n. Okay, so which means you still have more to copy. So I first move source PTR forward. So I source PTR equal source PTR is link. Okay, then call list insert to insert the load pointed by the source data of the load pointed by source PTR. So I call list insert. I did an insert after the load pointed by my tail PTR, and the data to insert is source PTR is data. Okay. Now then, notice that you will insert data after the load pointed by tail PTR, right? Now we move tail PTR forward. So tail PTR equal tail PTR is link, and I will increase count by 1. So the count plus plus. So after this loop, we're done. After done, then we will return the head PTR. So return head PTR. Okay. Now, if we try to run the program, success. Oh, we notice it's not good. Is because I did not uncomment whatever in the main function yet. So I did uncomment the code for test 4. Now let's try again. Hopefully we pass it. Now you see you will get a 10 out of 10, right? So we will get 10 out of 10. We pass all the test. Okay. So if you have any questions, please give me an email.